So in this session, I will give a review for your first exam. And this will be the first part of that review. Okay, so let's have our first problem in here. Let f of x, y equals square root of x minus 1 squared plus y plus 1 squared minus 25. First problem is we want to find the domain of f and sketch its graph on the Cartesian plane. And then the second problem is find the local linear approximation of f at the point p 6, 11, and then use this local linear approximation in order to estimate this value or the value of this f of 5.88, 11.02. Okay, so let's start with the domain. Let's start with the domain. So we have a square root function there. So of course, you know that the argument inside the square root must be positive. So you need x minus 1 squared plus y plus 1 squared minus 25. This must be greater than or equal to 0. Okay, and then we'll just have to move the 25 to other side of the equation. We will have x minus 1 quantity squared plus y plus 1 quantity squared. This is greater than or equal to 25. So greater than or equal to 25. And of course, if you look at the equality, you just have a circle. Now, we want this guy here to be greater than or equal to 25. It means you are looking at the outside of the circle. So in here, you have a circle. So let's just write it here. The domain of f, okay? So this is equal to the set of x comma y. So x comma y in R2 such that x minus 1 squared plus y plus 1 squared is greater than or equal to 25. Okay? And then for the sketch, you start with the circle centered at 1, negative 1. Okay? So this is 1, this is negative 1. You have this center here. And then you have what? Circle of radius 5. Okay? Circle of radius 5. So 1, 2, or 1, 2, 3, 4. And I don't have enough space in here. Let me adjust. Let me adjust this part in here. You know what? I will put it here. And then I have 5 in here. And then, of course, you need it to be bigger than that. And then let's have, so this is 1, 2, 3, 4, 5. So we have something like this guy here. Okay. Then let's just estimate this. Okay. And this is solid because we also want the equality. Okay, we also want the equality. So 1, 2, 3, 4. So you have something like here. Okay, pardon my drawing. Believe it's a circle. Just pretend that it's a circle. Yeah, actually, I can do this. Why did I have to do that one? Let me adjust this. Let me erase this part because I can use this. Okay, so pretend that it's a circle. Center that, well, it's already a circle, but pretend that it has, radius equal to 5. Okay, so let's say this is a circle of radius 5. Radius 5. And the domain, it's outside. The domain, it's the outer part of that circle, of the disk. Okay, so that's our domain. Okay, so that's for the first part. For the second part, we want to find the local linear approximation of f. So this means that we need L of x, y. This is what? F of x naught comma y naught plus partial of f with respect to x delta x. Okay, partial of x partial of f with respect to x delta x, that's x minus x naught, plus partial of f with respect to y delta y, and delta y would be y minus y naught. Y minus y naught. So we need partial of f with respect to x and also partial of f with respect to y. Oh, by the way, we have to evaluate this, right? We have to evaluate this at the point 6, 11. So don't forget about that. So let me adjust this here and insert the evaluation x naught comma y naught, and then for the other guy also, this guy here we evaluate at x naught comma y naught. Okay, and let's see. First, partial of f with respect to x, it's just derivative. We hold y as constant, so we will have here x minus 1 square root of divided by square root of x minus 1 squared plus y plus 1 squared minus 25. And notice you have actually 2 times x minus 1. Okay, 2 times x minus 1. So originally you will have here 2 times x minus 1. On the denominator, you have 2 square root of something. So the 2 cancels each other. Okay, this guy here will cancel this guy here. That's why I just wrote x minus 1 up there. Okay, and then of course same story for the y. We have partial of f with respect to y. We'll just have y plus 1 divided by square root of x minus 1 squared plus y plus 1 squared minus 25. Same story. Okay, and then let's just write here at the point P, which is 6, 11. 6, 11. What is this? Let's start with f of 6, 11. So this is equal to what? 6 minus 1, that's 5 squared, plus 11 plus 1, that's 12 squared minus 25. So this is equal to square root of, this is just square root of 12 squared, okay? Square root of 12 squared. So this is just equal to 12. So this is nice. So we will have partial of f with respect to x at 6, 11. We will have 5 over 12. And then partial of f with respect to y at 6, 11. This is equal to 1. Correct? And we also have we have this f of 6, 11, which is equal to 12. So therefore, the linearization will be, so L of x comma y, we have 12 plus 5 over 12 times x minus 6 plus 1 times y minus 11. Okay? So this is the local linear approximation. Okay? And then let's just do this. F of 5.88, 11.02. This will become 12 plus 5 over 12 times 5.88 minus 6. That's negative 0.12. And then plus y minus 11. So 11.2, that's 0.02. Okay? So if we just simplify this, what do we get? We have 12 minus 0.5 plus 0.02. Do I have that? No, 0.05 for this. 0.05 plus 0.02. And this is equal to what? 11.97. So this is the approximate value of f evaluated at 5.88, 11.02. Okay? Questions? Okay. Thank you. Next problem here. Show that the limit of x squared y cubed over x to the 4 plus 2y to the 6 as xy goes to 0, 0 does not exist. So in here, we just need to find two paths so that along those paths, the limit are different. Okay? Let's see. Let's start with the obvious one. Along the line x equals 0. Okay, along the line x equals 0, so you will have the limit x comma y goes to 0 comma 0 of that function x squared y cubed over x to the 4 plus 2y to the 6. And along the line x equals 0, this is just the limit as y goes to 0. Okay? Y goes to 0 of 0 over 0 plus 2y to the 6. And of course, the denominator, it's not 0 because your y only goes to 0. Okay, but the numerator, it's constant 0 because you let your x equal 0. So this is equal to 0. And then you choose another path. You can choose y equals 0, but along that path, the limit is still equal to 0. So instead, let's use a different curve. I'll be using, say, along the curve x squared equals y cubed. Okay? X squared equals y cubed. If you're curious, the graph of this is something like this. So it's something like this here. And then something. So it will go to the point 0, 0. Okay? So anyway, along that path, let's solve for the limit. Limit as x comma y goes to 0, 0. This is equal to, the function it's x squared y cubed over x to the 4 plus 2y to the 6. And along that path, x squared equals y cubed. So we'll just have here, let's replace x squared with y cubed. So the function here, expression here will just be in terms of y. So we will have y approaches 0. And notice that as y approaches 0, x will also approach 0. So we still have x comma y approaching 0. So x squared equals y cubed. Numerator becomes y to the 6 divided by x to the 4. That's x squared squared. So you will have y cubed squared. Okay? So y cubed quantity squared plus 2y to the 6. But y cubed squared, that's y to the 6. So if you simplify this, you'll just have the limit as y goes to 0 of y to the 6 over 3y to the 6. And therefore, this is just equal to 1/3. Okay? So these two guys here, they are not equal. Okay? Not equal. Therefore, limit does not exist. Okay? Questions? Now, on the exam, you don't have to, I understand that sometimes you have to try several paths, okay? You have to try several curves before you get different answers, okay? You can just give two curves with different limits, okay? So maybe what you can do is, try the path on a scratch paper, okay? Find the limit using one path, and then on another path, and then when they are different, just write those two paths on your exam paper. You don't have to write everything, okay? And I say you don't have to write. It means you can still do it if you want to do it. But you see, if you write two paths with the same limit, I won't check the other one. I'll just skip it. Okay? So especially if we ask that the limit does not exist. If we ask that, show that the limit does not exist, we are sure that the limit won't exist. Okay? If we ask the question differently, say, show that the limit does not exist or prove that the limit exists, then maybe you can try several paths. and just check that maybe you can claim that the limit exists. So you have to prove that, okay? But what I'm saying is you just need to pass with different limits. You don't have to write all the trials that you did, especially on the exams, okay? So questions on this problem? Okay. All right, so thank you. Let f of x comma y equals y plus tangent xy squared. Find the directional derivative of f at the point 0, comma 2 along the direction of the vector v. The vector is -1, comma 3. Then for the second problem, under this, if x equals ln of s and y equals r over s, find partial f with respect to r and partial f with respect to s when r comma s equals 2, comma 1. So first directional derivative, we will need the gradient of f. Okay, we evaluate the gradient at the point 0, comma 2. And then we have the direction vector here. It's not a unit vector, so we need the unit vector. Okay. So for number one here, we have, let's normalize. You have the vector v divided by the norm of v. So this is equal to -1, comma 3 divided by square root of -1 squared plus 3 squared. So -1 squared plus 3 squared, that's 10. So we have square root of 10. So this one here, it's -1 over square root of 10, comma 3 over square root of 10. You don't have to rationalize this, okay? So you can write the expression in this form. It's one comment. Another comment, please do not convert to decimals if the problem does not involve decimals. Some of you converts this square root thing, this fraction thing to decimals, but please avoid doing that, because sometimes when you convert to decimals, you just round off to nearest 2 digits, 3 digits. Okay, if you round off, okay, it's not the exact answer, it's just an approximation to the actual answer. So you don't have to convert to decimals. Okay, dokie. So we have the unit vector. Then let's find the gradient of f. So this is what? First component, it's the derivative with respect to x. So for that case, what do we have? Derivative of tangent function. Okay, that's secant squared. We have the argument x times y squared, and then by chain rule, we multiply by y squared. That's the first component of this gradient. For the second component, we need partial of f with respect to y. So we will have here 1 plus in here we have again secant squared xy squared. And then by chain rule, we need to multiply by the derivative of xy squared with respect to y. So this will be 2xy. Okay. And then at the point 0, comma 2, so gradient of f evaluated 0, comma 2, you'll have secant 0, that's 1, and then you have y squared, so you will have 4, comma, in here, there's an x in here, so this guy here will be 0, and then you'll just have that 1 there. So 4, comma 1. Therefore, the directional derivative will be what? The dot product. So gradient of f evaluated at 0, comma 2 dot with that unit vector v divided by the norm of v. So this is equal to negative, let me write the answer immediately. So you will have negative 4 over square root of 10, and then plus 3 over square root of 10. So this is equal to negative 1 over square root of 10. Okay? So I will accept this answer. Okay? And if you are really, if you really want to rationalize this, you can rewrite this as square root of 10 over 10. So any of the two is acceptable. Okay. Questions? For the second part of this problem, so we want partial f with respect to r. Okay. For this, so our function here, we have your x comma y. And then our x, this is just in terms of s. Our y, it's in terms of r and s. Okay. So partial of f with respect to r, this is equal to partial of f with respect to x times partial of x with respect to r plus partial of f with respect to y times partial of y with respect to r. But your x does not have an r, so this guy here will be 0. Okay? And if we recall, partial of f with respect to y, it was 1 plus 2xy secant squared of xy squared. That's partial of f with respect to y. Now, partial of y with respect to r, if your y is equal to r over s, that's just 1 over s. Okay? And then in here, r comma s, this is equal to 2 comma 1, which means that your x, that's ln of 1, this is equal to 0, and your what? Your y, this is 2 over 1, which is equal to 2. So you have the point 0 comma 2 again for x and y. So in here, partial of f with respect to r, evaluated r comma s equals 2 comma 1. This is equal to 1 times 1 over 1. So this is equal to 1. Okay. So this is partial of f with respect to r. Next, partial of f with respect to s. So again, this is just partial of f with respect to x times partial of x with respect to s plus partial of f with respect to y times partial of y with respect to s. And both of x and y have s. So we'll have to work on this. Recall partial of f with respect to x. That was y squared secant squared x y squared. And now partial of x with respect to s, that's 1 over s. Right? And then plus partial of f with respect to y, just like what we have above, that's 1 plus 2xy secant squared xy squared. And then this time, partial of y with respect to s, that's negative r over s squared. Okay? So, if we evaluate partial f with respect to s at the point r comma s equals 2 comma 1, we will have, what do we have? We have 4 times 1 over s, that's 1 over 1, plus again this guy here, it's 1, and then in here negative r over s squared, so you will have negative 2 over 1. So for this we have 2. So this is the value of partial of f with respect to s evaluated at the point r comma s equals 2 comma 1. Okay. Questions? Okay, thank you. Next problem. Determine partial z with respect to x and partial z with respect to y if the equation z cubed minus x ln of z plus y sine of xz minus y equals 5 defines z as a differential function of x and y. Okay? So we can do implicit differentiation, you can do chain rule if you want to, but let's just use the formula. Okay, so if we let f of x, y, z, okay, a function of 3 variables, to be z cubed minus x ln of z plus y sine of xz minus y. Okay, then let's get the partial derivatives of capital F. Okay, then f sub x, start with x sub x. This will be negative ln of z plus y. So you will have here y, derivative of sine, that's cosine of x xz minus y, and then derivative of xz with respect to x, that's z. So zy or yz. So this is your f sub x. Let's have x sub y. So we have chain rule, we have product rule for this. So we will have y cosine of x z minus y times derivative of negative y with respect to y, that's negative 1. Okay. Then plus we have sine x z minus y. And then f sub z. So for this, we have 3z squared minus x over z. And then for this, for the third addend, we will have, so let's do this. X, y, cosine x, z minus y. Okay. So we have partial z with respect to x. This is equal to what? Negative f sub x over f sub z. Correct? And therefore, we will have ln of z minus yz cosine x z minus y divided by 3z squared minus x over z plus xy cosine x z minus y. Okay. And then for the other one, partial z with respect to y, this is negative f sub y divided by f sub z. So this is equal to, we have f sub y and we have negative there. So we will have y cosine x z minus y minus sine x z minus y all over f sub z. So you have 3z squared minus x over z plus xy cosine x z minus y. So you can write the final answers in this form. Okay. So these are the final answers. Questions? All right. Thank you for the response. Next problem. Find the minimum and maximum values of the function f of x comma y. Yx equals yx squared plus y subject to the constraint 2x squared plus y squared equals 4. So you have this, and then you can use any method. Let's say, let us use Lagrange multipliers. Okay. So in here, we can let g of x comma y to be the function 2x squared plus y squared. So we will need to solve gradient of f equals lambda gradient of g, and your g of x comma y equals 4. Correct? And therefore, let's see gradient of f. So you will have, let's have partial derivative with respect to x first. Partial derivative with respect to x, that's 2xy equals, for the function g, you have 4 lambda x. And then partial with respect to y, we have x squared on the left-hand side. X squared plus 1. Okay, x squared plus 1. And then on the other side, we have 2 lambda y. And then, of course, we have 2x squared plus y squared equals 4. So we need to solve this system. Let me label these equations as equations 1, 2, 3. Okay. So let's look at equation number 1. Okay. From equation number 1, we'll have the following. 2xy minus 4 lambda x equals 0. We can factor out 2x, and we will have y minus 2 lambda equals 0. Okay? So, from here, if x equals 0, then in equation 2, actually in equation 3, then in equation 3, we have y squared equals 4, or we have y equals plus and minus 2. So we get the points 0, 2, 0, negative 2. Correct? Now, if x is not equal to 0, we will have y equals 2 lambda. Okay? Y will be equal to 2 lambda. Okay? If we have y equals 2 lambda, then in equation number 2, we will have x squared plus 1 equals 2 lambda times 2 lambda. So this is equal to 4 lambda squared. Or we have what? Or we will have x squared equals 4 lambda squared minus 1. And then in equation number 3, okay, then in the third equation, what do we get? 2x squared plus y squared equals 4. But x squared, it's 4 lambda squared minus 1. So you have 2 times 4 lambda squared minus 1 plus y squared, but y equals 2 lambda. That becomes 4 lambda squared, correct? And this is equal to 4. So if we simplify this, what do we get? You will have 8 lambda squared plus 4 lambda squared. That's 12 lambda squared. So you will have 12 lambda squared minus 2 times negative 1. So that's negative 2. So we have minus 2 equals 4. Okay. Thus, lambda squared, this is equal to what? 1/2. Okay. Thus, lambda squared equals 1/2. So, what do we have? Lambda squared or lambda equals plus or minus 1 over square root of 2. Okay. So if lambda equals plus or minus square root of 2, thus the value of y will be plus minus 2 over square root of 2. This is simply square root of 2, correct? So plus or minus square root of 2. Okay? And your x squared, will be what? So x squared, this is equal to 4 lambda squared minus 1, but lambda squared, that's 1/2. So you will have 4 times 1/2, that's 2, minus 1 equals 1, right? So what does this mean? If your y equals square root of 2, your x will have either plus or minus 1. If your y is equal to negative square root of 2, your x is still plus or minus 1. So we have those choices. So x equals plus or minus 1. Okay? All right. So what are the points that we have? So the points are, we have 1, comma, square root of 2, 1, comma, negative square root of 2, negative 1, comma, square root of 2, and then negative 1, comma, negative square root of 2. Okay? So we have to check these 1, 2, 3, 4, 5, 6 points. Okay? So we have the point P. and then you have f evaluated at p. Okay, so for the first point we have 0 comma 2, and the other point is 0 comma negative 2. What is f of p? We'll have 2 in here, we have negative 2 in here. And then we have the point 1 comma square root of 2, 1 comma negative square root of 2, negative 1 comma square root of 2, negative 1 comma negative square root of 2. For 1 comma square root of 2, we have 3. Okay. And then, sorry, why is this 3? Why is this 3? We have square root of 2, square root of 2 plus square root of 2. And then this is equal to 2 square root of 2. And then for the other one, just check, this is negative 2 square root of 2. For second from the last, this is 2 square root of 2 again. And then finally, we have negative 2 square root of 2. And among these four values, 2, negative 2, square root of 2 square root of 2, and negative 2 square root of 2, we have the maximum value. The max value of f, max value of f is 2 square root of 2. The mean value is negative 2 square root of